Hey guys, welcome to another video, and in this video I will be discussing the classification of differential equations. So the goal of the previous videos was to introduce you guys into what a differential equation is, and basically just give you the idea that we're not just solving for a value, we are solving for a function that fits the behavior described by the equation. And that brings us to this video where we will talk about how we classify those equations. So the first characteristic that we classify a differential equation by is its order. So when we talked about slope fields, we had an equation that looked like this, where this guy is the first derivative of our unknown function, and it is a function of x and y. And since we are dealing with only the first derivative, we call this a first order differential equation. So what order means is the term that carries the highest derivative. So for example, if we had this equation and we recognize that we have a second derivative in this equation, that we call this a second order differential equation. So what about this? Y triple prime plus y double prime plus y is equal to 0. Well, we have a term that has the second derivative of our unknown function y, but we also have a term that carries the third derivative. And like I said before, we characterize the order of an equation based on its highest order. So in this case, we would call this a third order differential equation. So in general, if the highest order derivative is the nth derivative in an equation, then we say that it is an nth order differential equation. So the second way that we classify differential equations is by its linearity. And by this, I just mean, is it linear or is it nonlinear? So in general, we can classify a differential equation as linear if it fits this form right here. So here you can see that we have combinations of all of the derivatives of our unknown function y, and all of the coefficients of these derivatives are all functions of x only. And on the right side of the equation, we have a function of x. So if we can write a differential equation of this form, then it is linear. So we can kind of simplify this into a couple rules. The first is that coefficients cannot have y or derivatives of y. So this just means what I have circled in blue here cannot have y or a derivative of y, meaning it is only a function of x. The second rule that we can break this down into is that our function y and all of its derivatives are to the first power, meaning that there is no y squareds, there's no y double prime squareds, or there's no y triple prime times y prime, and stuff like that. So these two rules describe a linear differential equation, which is this form that I have written up here. And if it does not fit this form, then we call it nonlinear. Okay, so here I have a few examples that we can practice classifying these differential equations with. So for each of these, we're going to decide its order and its linearity. So on this first example, we see that the highest order is this second derivative, so we call it a second order differential equation. And now let's decide if it's linear or not. So each of the terms that contain our function y, which are all three of these terms, they are all to the first power, so that's good. And they all have coefficients that do not include y or a derivative of y, because they are all 1. And on the right side of the equation, we see that it is only a function of x. So this fits our general form that we defined earlier. So we can say that this is a linear differential equation, a second order linear differential equation. So on the second example, let's categorize it by its order first. And we see that the highest derivative is the first derivative, so this is a first order differential equation. And the coefficients are all functions of only x. They're just constants, same thing. But on this side, we have a y multiplied by x. But we can recognize that we can rewrite this equation as y prime plus 2 minus 2x times y equals 0. And now the coefficient of y is only a function of x. So even though this y term showed up on both sides, we can always rearrange it into a way that fits our general linear form. So we can say that this equation is a first order linear differential equation. So let's move on to this third example. Our highest derivative in this case is y triple prime, so this is a third order differential equation. And we see right here that we have cosine of y. Now this is not y or its derivative to the first power, and there's no way that we can turn cosine of y into a function of x times y. Therefore this is nonlinear. So this is a third order nonlinear differential equation. And in this fourth example, so we see this cosine again, but this is a function of x as a coefficient of y double prime, so that's okay. But right here, we have 5y prime times y. So this is like saying we have 5y prime as a coefficient for y. And this is not a function of x only. This includes our unknown function y. Therefore, we can conclude that this is a second order nonlinear differential equation. So hopefully you guys can kind of see the pattern here, and this will help you classify a differential equation. So in this course, we are going to mainly concern ourselves with first and second order linear differential equations. And the reason why we're going to focus on those is because we can model a wide variety of systems using only first and second order differential equations. And the reason why we want to focus on linear differential equations is because we can obtain simple analytical expressions for the solutions of those equations, as opposed to nonlinear equations where most of those need to be solved numerically because there are no analytical solutions to them. However, we will take a look at a couple forms of nonlinear equations and we will solve those. And we'll also take a look at a couple higher order differential equations. But for the most part, we will only be concerned with first and second order linear differential equations because those are the most important.